The events in the Middle East clearly demonstrate that having our own nuclear industry is one of the highest state priorities. But few people know that right now, Russia is reviving the full cycle of beryllium production, a strategic metal for the nuclear program of the future, on its own territory. The nuclear race continues. Why were these technologies lost for decades? What does Kazakhstan and the Americans have to do with it? And most importantly, what new breakthrough project made us need our own beryllium? We'll talk about that as well as the new Hero of the Week after a brief summary of positive news. The Kaliber carrier submarine Yakutsk has joined the Navy. Another batch of upgraded artillery fire control systems has been delivered to the troops. A crab fishing vessel of Project 03141 was laid down in Nakodka. A plant for the production of robotic equipment has opened in Orenburg, a hot-rolled rebar plant in the Rostov region, a spare parts production facility, and a paper products plant in the Ulyanovsk region, the second phase of a paper products plant in the Kaluga region, a glass processing workshop in the Vladimir region, a waste processing complex in the Tomsk region, and a robotic livestock complex in the Lipetsk region. This year, Russia is already starting a project to resume beryllium mining at the Ermakovskoye deposit in Buryatia. This is a remarkable event with far-reaching consequences. But to understand it, we need to delve a bit into the context. Beryllium is a metal that, thanks to its lightness, hardness, and heat resistance, is indispensable in the defense industry, aircraft manufacturing, rocket engineering, electronics, and electrical engineering. As an alloying additive, it is used to improve the quality of alloys, and also in nuclear energy, since, among other things, it is in demand as a moderator, absorber, and reflector of neutrons. More than 60% of the world's production comes from the United States, with China also being a leader. But in Russia, despite having significant reserves, mining has not been carried out since Soviet times. At the same time, our Ermakovskoye deposit in Buryatia is unique because of its high beryllium content, over 1%. It is relatively easy and profitable to extract it here. In the Union of Soviet Socialist Republics, an industrial site was set up at the deposit, from where the ore was sent to the Zabaikalsky mining and processing plant for further processing. But in 1989, the process was stopped. Why did Gorbachev proclaim openness and a course toward disarmament? They sprang up like mushrooms after the rain. Anti-war democratic movements demanded the elimination of nuclear weapons and a halt to research. Mining was shut down not only in Buryatia but also at another rich deposit, the Ural-Mariinsky mine. Soon the country was torn apart, and this gave rise to a new, much more serious problem, which we are only beginning to address now. The thing is, it's not enough to just extract and separate beryllium from the ore. It also needs to be processed. This is a complex and dangerous process due to its high toxicity. In the Union of Soviet Socialist Republics, this was done at the Ulba metallurgical plant in the city of Ust-Kamenogorsk, Kazakh Soviet Socialist Republic. We built the plant itself back in 1949 to supply uranium for the atomic program. In 1959, it started producing a beryllium, and after the collapse of the Union, it became foreign to us. The problem was not only that we lost access to a strategic enterprise, but also that huge stocks of enriched uranium and perily remained on the factory's territory. That would have been enough to create several dozen atomic bombs. But for independent Kazakhstan, this was a burden. Maintaining and guarding them was expensive and dangerous, and Russia was busy with its own problems. The Americans turned out to be the most efficient. They carried out the secret Sapphire operation and flew 600 kilograms of uranium from the Ulba metallurgical plant to their own territory. In return, Kazakhstan gained access to modern Western oil extraction technologies and investments. Russia was not in a position to prevent this, and no conflict arose. Later on, we became the main buyer of products from the Ulba metallurgical plant, and we remain so to this day. However, it was necessary to find a solution for mining and processing on our own territory. Leading Russian institutes joined in the development of full-cycle beryllium production technology from ore to metal. New laboratories were opened and the necessary facilities were established. The task was not to recreate Soviet practices, but to develop a safer and more modern production process. Judging by the recent announcement about the imminent revival of mining at the Ermakovsky deposit and the Mariinsky mine, we have either already solved this task or are close to it. So already this year, the construction of a large plant will begin in Reactor. This means that in a few years, the country will finally start receiving its own beryl, not imported. Now, the main question is, why do we need it? We have a theory. At the end of April, Vladimir Putin gave instructions to speed up the creation of a research molten salt nuclear reactor. This is another unique project that the country is working on. The fact is that nuclear energy has no future without solving the issues of nuclear waste processing. Russia has advanced much further than others in this area and is preparing to transition to a two-component nuclear energy system based on fast and thermal reactors. This will significantly reduce the amount of waste, but it still won't solve the problem of so-called minor actinides, long-lived radioactive isotopes. They make the main contribution to the high radioactivity of the waste that remains after fuel reprocessing. But they can also be disposed of using a molten salt reactor, which is what we're working on right now. And in it, scientists have decided to use a mixture of lithium and beryllium fluorides. And a lot of it will be needed if the technology is successfully implemented. This, in our opinion, is one of the reasons for the renewed interest in this complex but essential metal. So, as you can see, everything is interconnected, and many of the mining projects we are restarting are necessary for the transition to a new technological paradigm. When it comes to breakthrough technologies, it's better to rely on ourselves rather than on foreign suppliers. We will keep you updated on the events and tell you more in the next episodes. Next up is the announcement and the rescue story. Colleagues, do you hear the unanimous howl of the armchair experts? Why is Russia spending billions on a new scientific fleet? Let me answer. This is not a luxury. It's a matter of survival. The Soviet fleet was the terror of the West, but after the collapse, we lost almost everything. Now we're building new ships, Academic Tryoshnikov, Severny Polius, Ivan Frolov, but that's not enough. Three main reasons: military security, studying the seabed currents and eddies is vital for our submarines, and for protecting our infrastructure and food supply. Without scientific quotas, there is no fishing, so we are already being restricted in Antarctica. The wealth of the Arctic, to prove our rights to the shelf with oil, gas, and metals at the United Nations, we need research. Yes, those very same legendary Soviet deep-sea vehicles are the ones they want to restore after a long period of conservation.